All right. Hello everyone, it's April the 6th. Well, surprisingly, I finished my work for the day. All right, let's do this. What are we having today? I think it's an old problem. Must have done it before. Partition equal subset sum. Given nums return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal or false otherwise. So we need to split. Well, we can do a check, a sanity check. If it's odd, then you know it's not possible. For example, example 2, I think the total sum is 11, which is not possible to be split into 2. So you do that first check, and then you need to see if it's true or false. Well, then you have to have the sum. You know that, right? So if you know that, then all you need to do is to see if it's possible to fit the numbers in. And each number has to be in one or the other. So you can ask the question, like whether this number should be in one or in the other, right? I just say this number has to be in this one and in this one. So maybe there is a, I don't know, a DP in it. What would the DP be? So the DP will be, let's say, the remaining sum. They have two parts, right? Oh no, it's just, okay, yeah. So you have the total sum, you find half of it. So the question is, can you find a group, like a subset that adds up to that sum, right? That's it. That's all there is to it. And then all you need to do is try to see, okay, if this number is in, then we'll do the DP for the remainder, right, with minus this. Or if it's not in, then it's the remainder. Yeah. You just run through this, and then you'll get it. And what we want is just a true or false, right? We just want a true or false. And can we do it not top down? Can we do it bottom up? So we say if this is in, right? So it's gonna be dp. Let's say dpij is equal to whether it is possible, okay? Whether it is possible whether it is possible to find a subset in nums I to the n that adds up to value j. Okay, so now I have this, Okay, so I say this is, I have dpij for this. We go from right to left. So now I need to compute this, right? It's a dpi minus 1, right? So j will have to go from, 0 all the way to the target, right? From 0 all the way to the target, because we don't have to go larger than target, because we just want to know if it is possible to do that. So for each for each j, right? For each j, what we want to know is if I include this, right, then we need to go dpi j minus whatever this number is, right? Minus whatever number is. Now we need to see if it's if this is possible, if this is true or false, or I don't include this, then this will equal to dpi ij. right? So it's just dpij or dp this for every single possible way. Of course, the j, we're gonna go from, I don't know, from 0. And 0 will be false, so we don't go from there, we go from itself. Itself is also going to be, because if it's a self, then the next one will also always be 0. Which is fine. Which is fine. We can just go from itself. Okay, so we have a strategy. Let's see if we can code it up mighty fast. Alright, so first thing first, we will do this. This is 416. Use dp, where dpij, okay, is equal to is the possibility, is whether, right, whether it is possible to find a subset in nums I towards the end whose sum is j. Okay. And then the answer will just be dp0 with the target. Okay, so we can say int total, right? And then we say for int n of nums total plus equal to n if total mod 2 is equal to 1, then we just return false. Otherwise, target equals to total divided by 2. Okay, so now I have target. And then we will build, I wonder if we have, I believe so. I think we can do an optimized DP. It's just 1D. We don't have to do 2D because every time you check, it's always going to check to the right. And then we go from right to left, so we've always done it already. So what we can do is say std vector of int. We can do dp. Now this dp, what is this? Because if I want to find this, right, and I do I plus 1, which means it's another row, and then so the size has to be j, the largest. So I will do size to be target plus 1, and everybody is false. Okay, so this is actually boolean value. Okay, so with that, I can go from right to left, right? So for every one, I will go from this towards the end. Actually, no. I think it should be true for itself, right? Let me think. So yeah, so we go from right to left. Actually, no, we go from left to right. Right, we go from left to right on the sides, and then we say, is it possible to use that by itself? And then we do plus 1, right? And then plus 1, if it's larger than, then it's not possible. Right? If it's larger than, and if it's a 0, that should be true. But if it's larger than, but it's not a 0, that should be false. Okay, so yep, so we'll do that, and then we do the next one. So we have value, but we'll go for the next one does not exist, and that will be false. Right, so we go through every single one, and then we move on to the previous value, and the previous value, we'll look at this. Ooh, now I start wondering if it's even possible. But if we go from right to left, I think it's fine. Because the right to left... No, we need to go left to right on the J. Because we need to use... Right, we have this J. Well, J will be minus this. We probably still need 2 though. I think 1 probably is not enough. 1 probably won't cut it. Right, I think 1 probably won't cut it. Yeah, I think 1 probably won't cut it. Okay, let's just use 2. Because it will always go to the next one, right? So we just use 2. So for int I shall equal to nums dot size minus 1. I logical to 0. I minus minus. Okay, so this is I. Actually, I can say dp. Just consider the last number, right? Nums dot size minus 1. This is the last number. Okay, and for the last number, the only possibility is for itself. Anything else is not possible. So this will equal to true. Okay, and here I can go from this one, right? I'll go from this one, and from this one I can go for int j will equal to I, right? J smaller than target, actually smaller equal to target. Okay, j plus plus. So we just need to find out the dpj, right? We need to find out dpj. Now we need to find out dpj. J is a target, so I have the remainder, right? So this minus will be 0, right? We start with 0. And then as j move on, it would just gonna be 1, 2, 3, 4, right? So we do 0, and we try to do 1, try to do 2, and every time we do, right, we will have to, What are you saying is if we sort nums, then we always handle the biggest one first, right? And then we have something smaller, right? And then we have the target and minus this. So we'll fill out, from 0, right? We fill the getting bigger and bigger until we find the target. And as we go, it's guaranteed. I guess at the beginning is just the end number. Let's say is 100. So 100 says to be true, and our target, let's say, is 1000. Okay, so 100 says true. Next, let's say is 80, right? So we say we can include 80. Then we'll do 1000 for the next one. So we actually do 1000, right? If I don't, then the next one will do 20. No, not 20. So like 1000 minus 80. Right, 1000 minus 80. So we'll do that, which is not possible, right? So you just, you go through every single one. I don't know if we need to have a second one, but let's just have a second one, which means we're gonna set a second one, which we call it temp. Okay, that's exactly the same. All right, so for each thing, right, for the next one, if it's a 0, right, so 0 0 should always be true. What does 0 0 mean? 0, because the number will never be 0. It says the number is never 0. So that means a non-existing number will reach 0. It's always going to be true. So what I'm going to do is I also do dp0 is equal to true. Okay. So now we can say is the current value is j. So the option 1, right? Option 1, do not include nums I. So we directly say temp j, right? Temp j will equal to temp or equal to dpj. That's do not include. And option 2 is include nums I. So to do that, we say temp j or equals dp j minus nums I. So this is actually not true. This should be nums I. Right? It should be nums I. Starting from nums I, so this will become dp0, right? dp0. So if it's a 0, then we say it's true because j is equal to nums I, and then we're just saying from here, if I want to do just by itself, yeah, it always works. But then j will get bigger, and then we'll try to see if it works, right? So we go through all that. No viable overload of or equal. Wait, really? This? Huh? What? C++ doesn't have or equal? They have and equal. I don't know what happened here. Expected expression. I don't know. I'll just do that and I think it will work. Alright, so yeah, we have option 1 and we have option 2. And well, we keep going, and at the end we'll return dp0. No, dp, ooh, dp what? dp target. That's what we're gonna return, right? Because we go all the way to the front, and then it should be dp equal to temp, right? We go all the way to the front, and then we just try. We try this for everyone, and then we get us. So OMN, where m equal to sum nums divided by 2, n is len nums. Alright, let's see if it works. Looks okay. Try it. Lately I just got these wrongs so often, so I don't know what happened. So 14, 9, 8, 4, 3, 2. Alright, so that's 23, 31, 35, 38, 40. So the target is 20, right? The target is 20. So the target is 20. For 2, I just have 2 is good, right? So I have 2 is good. 3, oh, that's how you debug this. $20. Yep, I see 20. This is 17 plus this is 20. Let's see, where do we get wrong? So j from this and j smaller equal to that, and then this is true, right? Oh, wait, hold a second. Oh, yeah. Yeah, so for start, the dp0 is true, and then this is just dp2, right? 2 is true. Now we have 3 comes in. Oh, I think I forgot to do temp 0 equal to true. Well, that's still not right, but it's okay. Temp 0 should be true. And then we try it. So we start from j is, that. And we say we want to not include, right? Not include, so we go dpj. We just good, or we include. That will be j minus nums I, so it will be 0, right? And then dp0 is true, so that will be true if I want to get to 3, right? Now I want to get a 4, it will be 5, right? If j is equal to 5. Now j is equal to 5, and temp j shall equal to dpj. dpj will be false, and our temp j will go dpj 5 minus 2. 5 minus 2 is 3. No, 5 minus 3 will be 2, so it will be dp2. So dp2 is true. So dpj shall be true. Okay, so there is some issues with this. I need to debug it. Not ideal, but yeah, and just how things are these days. Very rarely we get the first shot correct, but it's all right. It's absolutely all right. So we'll save this. Ooh, have to change this one as well. So this is a cam partition, and then this is nums. Now let's build this. Okay, now we will run it. Okay. So I is equal to 4. 0, 1, 2, 3, 4. Okay. And we have a temp. Temp 0 is true. So j equal to 3. So temp j. So let's go temp. Temp. Okay, and then temp. Boom. 3 is true. That's correct. Next, 4 shall be false. 5. 5 is true. Yes. 5 is true. Then everybody shall be false. Okay. So dp equals this. Go. Now we have a new one. So now j equal to 4. Right? 4 I shall see 4 is true. 5 shall be true. Right, 5 shall be true. 6 shall be true. Okay, 6. Temp j is false, but 6 minus 4 is 2, so dp2. Oh, I think dp2 becomes... Oh. hold on, why DP2 is false? Because when we do 3, right? When we are doing 3, we start from 3, right? And then we go through everything. But the smaller than 3, we didn't really take care. Now, actually, this means we should only keep one DP array. Because as we go through, right, as we go through every single time, if starting from this towards the end is for something as possible, and then you go to a previous one, and then you want to know, it's not from this, like from every single one, so they should all be odd. Which means I think we can simply say we don't do this, right? And we just simply say dpj will equal to dpj, and then do that. Now we do that. Okay, what do you think about this? Looks good. We can simplify, right? Simplify this by using a 1D DP array to keep track, yeah. Yeah, we can overwrite previous decisions that's not really previous, like we can overwrite previous decisions, because if dpij, right, is true, and dp, let's say I minus 1 j is not true, I is true. If this is true, then dpi minus k, where k is smaller or equal to I, will always be true, because we say it's from I to the end, right? We just say from I to the end, we can find a subgroup that add up to j. So as long as it becomes, then we should be good. Which also means we don't have to go through every single thing. We can. There is also an early exit, right? There is also an early exit, as long as we find some dpi target equal to true, we can terminate the program and then return true, which means we can go blah 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 blah. It was a target. Yeah, we did this one. We have to go through everything, but once we go through everything, we can say if dp target is true, then we just return true. Otherwise, we just keep going, and at the end, we return false. So this is early exit, right? Early exit. All right, so we are equipped with 2 updates. Let's run it one more time, make sure everything goes smoothly, and we will submit this. And we got it wrong. What? Jeez. Output true. How do you output true? DP target. Target is 4. How did you get a 4? I have no clue. Target is 4, so we start from 5. We don't even go through anything, right? And now we go 2. 2 Yeah, 2 is true, but 3 is false. 4. Oh, shoot. Darn. This is why sorting is important. This is why sorting is important, because you shouldn't be able to use the value to your left, right? We only have 1, 2, and then we need to do another 2. Oh, let me think again. Oof. But we are allowing duplicates, right? Jeez. We do allow duplicates. So if we do allow duplicates, so now we have a 2, and then a current value of minus 2 is 2, and we cannot use 2 again. How can we solve this more elegantly? Now, because we go from right to left, like if we sort it, it will be something big, right? So when we do that, if it's something bigger than the current value, then we know it's good, because we say they have to add something bigger than you, right? So we sort it, so it has to add something bigger than you. Yeah, so basically whenever it hits something smaller than you, that is, so we can end right there. However, what if it hits something equal to you? Equal to you. Equal to you. Position. Position. Can we use position instead of the value? Well, we are using the position, right? Ugh. We're saying if maybe what we should do is don't hit itself first. If I don't hit myself first, then we always have to do something bigger than me, right? Then I do something bigger than me, then they must all have been countered. And then once they're done, right, and then I do myself, right? Then I do myself. So what I'm proposing is, I'm proposing to sort this, and then this is all fine, right? So from this one, I go from this +1 to the end. So these will all be fine, right? And once these are gone, then I'll do, because I can always do myself, then I say dpj, right? So equal to dpj, or dpj is not really dpj, it's dp nums I shall equal to true, right? Because I can always do myself. I can always do myself, but I don't want to do it now. I want to do it at the end, just to make sure that when I'm going through this part, I only handle the part that's already been handled, right? So I won't like I add to myself, right? I won't add to myself, because I add 1, so I never add to myself. It's always going to be something bigger, right? Always going to be something bigger. Okay, so now the question is, if it has to be bigger than me, right? It has to be bigger than me. That actually is going to be because I need to add something bigger than me, right? Because I sorted it. It has to be something something either bigger than me or equal to me, because I sorted it. So it can be equal to me, it can be bigger than me. So I need to add at least myself. So I should start from 2 times, right? At least this much. Because if I don't start from there, like if I am 10, okay, and it's sorted, so the one value after me at least is 10. So I have to start from 20. If I go like 11, then I know it's not possible for 10 to be involved to get 11, right? So I had to do 2 times my current number, so I get to 20. And then I can say, okay, that's the next one. But then the next one, I don't do this right there, I do this at the end. So when I do it, the first thing I see, it will be myself, right? So if j is 2 times nums I, j minus nums I just equal to dp nums I, it's myself. And if myself has never been achieved before, then it will just be not possible. So it has to wait. Oh, okay. That's I'm not quite sure. Now we're in the territory of simply run it, test it, run it, test it. I guess that's why this problem is not really that simple. You see, this one is still wrong. I don't understand. I already made the modification. How come that it is still wrong? So yeah, so we have 5, right? So 5 is true, 0 is true, is what we start with. And now I is 1, okay? And nums I is 2, so j equals 4. Target is 4, right? So we say dp4, the 4 is false, and then 4 9 minus is dp2, right? But dp2 I haven't done it yet, so it's false. And then they come out, then dp2 equal to true, okay? And dp4 we haven't done it, and then we go to 1. So 1 I start from 2, all right? So we start from 2, so 2 minus 1, so currently is 1, which is false, okay? So now we do 3 minus 1 is 2, so that's true, so dp3 is true. And I do 4 minus 1 is 3, and dp3 is true. We're reusing something that you're not supposed to reuse. I say including the current, right, I can get 3. So the current with 3 is good, right? But I need to use the current. Now to do 4, I need to get 3. But that 3 should be without the current, right? Without the current. So we need to go back down. We need to go back to the two DP arrays, right? We have to go back to the two DP arrays. Yeah, because 4, I want to try to see if 4 is possible. So 4 minus 1 is 3. So it should be without 1 is 3 possible, right? Without 1 is 3 possible. So I need to I need to try 3. So okay, so what I'm saying is I need to get, let's say, I do have to have another one. So vector int, boolean temp. I believe I can do dp dot begin dp.end. I'm not sure. Can I do that? Maybe I can. All right, so I copy this, I do this. Now, of course, these are not dp. This is gonna be temp, right? This is gonna be temp, and this is gonna be temp. This is gonna be dp. So the dp will not have dp3 set, all right? And at the end, now in that case, that's fine. In that case, we have to set this one anyway, right? And then we can say if temp this, because it's the newest one, and then we'll say dp with a temp. All right, let's try. Let's see if this one works. Wow, this one is not as simple. I thought it's like 20 minutes max. We can get this one done. Okay, so all right, we do we dare? Okay, then we have to delete something. We cannot simplify it. Right, we cannot simplify it. But we do have an early exit. Early exit is true. Simplification is not. Ugh. We have more numbers. You gotta be kidding me. Okay, let's say this dp has to be total. Okay, let's say dp has to be total. For safety, dp has to be total. If dp is total, then for sure, would it be too big? 100 times 200. Yeah, I think it should be fine. All right, let's try. All right. So we got it after I don't know how many errors. Tons and tons. But we did get it 102 milliseconds. 62%. Was not the best. I feel like should have done better. But let's take a look. Last time was 2021. I was able to solve it after 2 round attempts. Today it was, well, technically also 2 attempts, but we also get a runtime error. All right, let's see what we got last time. Okay, it was LU cache. I'm pretty sure it's about the same. You see, I find the target, I get a counter. That's a little bit different. And what the hell is this? Counter minus equal 1. And I also get a maximum. I removed, wait, what? I have no clue. But anyway, I use counter. So I think, I see what I was doing there. So basically, for each unique value, I decide either use it once, twice, 3 times, up to counter number of times. That is what this one is. And then I'll go for the remainder, right? This is the remainder. And each one I'll just, I do the index and the target. Target with minus this. It is interesting that I did not include the possibility of not including. Oh, I don't know. I don't know why. Not including will be, Interesting. I did not include not including. It's like I start from 1, you see? I start from 1 to the counter value. It's like I always include 1, right? Always include this. I do not have a situation where I don't include this, right? Like I'm skipping this. I don't see it. So I don't know why I do it that way. It's for me, right? If you ask me, I think, why do I minus the maximum? Oh, because the max would definitely be included in one of them. So I can make the calculation faster. Okay. Fair enough. Fair enough. But still, I'm saying it has to including this. Or I would be like including this, right? We can change the DP. We say including this. What is it possible to get to the end? Because at the end of the day, the value must be included. Okay, yeah, that's possible. That is possible. And then I did something else. Is this like bottom up? Yeah, I did some bottom up. Look at that. Looks okay. This DP, I only have one DP. No, this is a 2 DP. This is 2D DP. 2D DP. This is I think, yeah, this is the front, and then, or yeah, this is about the same as what I did this time. Okay, what's this? I think it's just similar. Reduce space complexity. This is using only 1. No, 2. I have a temp. That kind of validates me, right? You have to use a temp. What is this? Remove max number. Oh, this is to remove max number. But it didn't really improve the performance too much. Oh, this is the one. It is knapsack, right? It is knapsack. I goes forward. I did it, right? I have 1 go forward. You didn't go forward. So I goes backward. This one goes forward. But it's supposed to be I goes forward and this go backwards. If j is larger or equal to nums I, and then we say dpj or equal to this, and then did not sort. Okay, I did not sort. So this one was saying for each number, we're trying to see ending at this number, right? So this is kind of a different way of thinking. So ending at I, nums I, can you get the j's? So I goes from the largest, okay? So j goes from the largest, so we try to see, because what I want to know is j minus nums I, right? I'll take it. I either take it or I don't take it. If I don't take it, then dpj, which is equal to dpj, right? Don't take it, which is equal to dpj. If I take it, then I need to know, given the current target, which is j, minus the number, which is to my left, right? To my left. That's why j has to be larger or equal to nums I, so it's to my left. So I want to see if that one is true or not. So it works because I'm updating dpj, which is the current one, and I'm doing the target minus myself. But this runs the risk of duplicate, right? I don't know. I mean, how is this not? Mm, how is this not running into the same problem that we had? Because it doesn't sort, right? I don't see any sorting. So for the current number, if, let's say, um, j minus nums I is equal to nums I. No, that's not right. So why did your solution didn't work earlier? It didn't work because I tried to reference a DP value that's just been computed right now. That's why it didn't work. I tried to reference a value that's been worked on right now because I'm going through them from small to large, right? So for, as I say, 3, right? 3 works, so I find a solution for 3 for 1. Then I go to 4, I need to find a solution for 3, but 3 has already been computed. So that's not right. But if I go from large to small, right, the j goes the reverse order, then every time we get, it's a big value, right? It's a big value. And it gets smaller. Why would that work? Because if you get a smaller value first, right? If you get a smaller value first, yes, if you get a smaller value first, you can say I can create a certain target, but then your target is bigger, so you will reuse that value. But if your target starts with big, right, and you will get a big value, and then the value you need to use is smaller, where it's guaranteed and not being used before. Ah, that is good. That is good. So that's how you use only one. Okay, let's see if we can try it. So this is solution 2. Same as solution 1, but using only one DP array. The trick is to now in my case, I go from right to left. I go from right to left, but it shouldn't matter, right? It shouldn't matter. I go from right to left. Then the value should go from left to right, but I did go from left to right. Right, I did go from left to right, and I go from left to right. So the first one I get is a smaller one, and as I go, it should require bigger and bigger. Right? It should require bigger and bigger. So I fill out a smaller one. The next one will require something bigger than what I just filled out. Right? So I fill out a 3. So the next one shall ask for I still don't understand. Yeah, it's just from small. You go big first. Okay. So you fill out here, here, here. So each time the new one will definitely not encounter the one you already filled. But if you go smaller to big, then you might overlap. Ah, okay. Trick is to go through. Right, go through the J's from large to small. This can avoid using a DP value that is computed in the current round. So this one also said I don't have to use this. I think these are fine. This is fine. We don't have to use this. So this is not. So I say from target, okay, J larger or equal to this. J minus minus. What? This is not the DP. Right, because J is going from the large, like very large. So if we go from very large, then it will stop, right? Go from very large. So this one will be a large number. DP, this will be a large. So it will not be something that's already computed, right? It would not be something that's already computed. Which also means I don't have to do this. And I'll do DP here, which is early exit. Okay, let's try. Oh, doesn't this look good? I think it looks good. So this is the trick, right? This is the only trick. And then I have early exit, so that's why this is going to be faster, because I have early exit. I'd expect this to be faster because we don't have the overhead of creating two arrays. Exactly, right? Exactly. That's how I'd expect it to be. No overhead, so it is faster. Pretty neat. Pretty neat. Well, have a look at this problem. First time I solved it back in 2020. 2020. Jeez. It's a long time ago. 2020, and then 2021, and then 2025. I haven't touched this problem for 4 years. But I think we did better than last time. We did have some errors have to go through, but overall it's not that bad. But we didn't figure out this one immediately. Yeah, this is a trick, right? This is a trick. Wow, I didn't realize that you shaved this off by half. Huh. Shave it off by half. Okay, that'll be it. That'll be it. Oh, LeetCode? It's a platform for you to do these toy problems. It's just something for fun, you know. You do it for fun. You have all these problems, and then you just try to solve them. Yeah, that's what it is. All right.